Truth be told, I'm going to just start this video the way I want to start it. Yeah, I'm gonna ask myself two questions, and I'm gonna try my best to think about it while looking at all of the data I have here right now. I'll try to like answer my own questions or like give myself more questions, like basically just explore. This this channel is basically me as a kid just playing games, having fun. But I've gotten older, and as a kid, I was like, I really wish I could do the stuff I did in these games. Or, I like read a lot of comics. I was like reading a lot of like DC comics. Like, I really wish I was a person who could do all of this stuff too. Or I was just like a kid with these cool ideas, but I never had the chance to make them. And now I'm like in my 20s, and I can figure shit out because I can think and think properly. Anyway, the two questions I want to ask myself is what is machine learning and how what is machine learning and why is it so cooked? Okay. Why is it so cooked? I have a paper here right now by who knows. I have no idea who wrote this paper. Check it out. It's written by uh Ajit Singh and a few other professors all in India. Foundations of machine learning. Because the thing is, when you're looking at machine learning and what exactly is machine and what exactly is the process of learning. Look at the machine, we look at, like certain, contraptions, devices, just a lot of things. But in this context, let's just say a system. And when we say a system that undergoes certain like instructions and stuff, you know what I'm saying? Just shit like that, bro. I don't know. You know, because like whenever we think about the word like or like just like the phrase machine learning, I always think about, like a robot, just sitting by a desk reading a book constantly until it figures shit out, or just figures stuff out. And we see like a lot of that machine learning, like, okay, cool. How exactly does that process even happen? And I think I kind of understand a bit more because I was looking at this dude, Jeffrey Hinton. This is like the godfather of like AI. So basically, in like the 1980s, this dude was thinking about ways to like, understand the human brain, but instead he figured out a way to make neural networks. I don't know it exactly. I haven't looked at this much. I need to look at it more. But like he's the reason why we have AI today. And while I was doing that as well, I was also looking at this video over here. But this is like maybe one out of 10 videos I've watched. I haven't like comprehended all of them, in most of them. Like right here, man, like around like 11, 12, some shit like around here.
Such a wide variety of.
And by finding common structure, they can encode things using the common structure, and that's more efficient. So let me give you an example. If you ask GPT-4, why is a compost heap like an atom bomb? Most people can't answer that. Most people haven't thought.
I like this
they
part.
think atom bombs and compost heaps are very different things. But GPT-4 will tell you, well, the energy scales are very different and the time scales are very different. But the thing that's the same is that when the compost heap gets hotter, it generates heat faster. And when the atom bomb produces more neutrons, it produces more neutrons faster. And so it gets the idea of a chain reaction. And I believe it's understood they're both forms of chain reaction. And it's using that understanding to compress all that information into its weights. And if it's doing that, then it's going to be doing that for hundreds of things where we haven't seen the analogies yet, but it has. And that's where you get creativity from seeing these analogies between apparently very different things. And so I think GPT-4 is going to end up, when it gets bigger, being very creative. I think this idea that it's just regurgitating what it's learned, just pastiching together text it's learned already, that's completely wrong. It's going to be even more creative than people, I think.
You'd argue that.
Like just him saying that makes you really think about, like, honestly speaking, like just from my perspective, it kind of changes the way I think about it. Because before I think I was one of those guys who's like, yo, ChatGPT is just, yeah, it's an LLM, it's a large language model. It's just, it's just basically just taking text from the internet and just like putting it on my screen and just using like a bit of machine learning to just, summarize the text it did. And in a way, you can say it is doing that. But like the more I read on about neural networks, the more I realize that, like, especially, like with like forward propagation, loss functions, backward propagation, nodes, neuron, I don't know, like just other stuff, like you begin to realize that there's like actually a lot of reasoning that's going on. The machine is actually like using all this data that you have to do low-key the exact same thing I'm doing right now. It's thinking, it's like, yo, why, why, why? It does this and does that. So there's a similarity in this, you know. Why is the color red red and why is the color blue blue? And then it's also like, why is the color red called the color red and why is the color blue called blue? And then it also, like like it just begins to like go down like into like a certain tunnel of why is red called red and why is blue not called red and why is blue not called red, stuff like that. It's confusing. The thing is, I don't understand it mainly as of yet. I think I want to understand it because I want to work on a project that does some things, because like I'm in uni right now, a computer science student, and I want to like build a neural network. I'm doing other stuff right now. I have a few. The thing is, it's basically summertime, so I have time to like like waste, and I'm gonna waste my time learning. I'm gonna waste my time doing this. Obviously, I'm gonna have fun, blah. I'm in my 20s, I'm gonna have fun, but I'm gonna waste my time trying to learn as much as I can about this because I find it very interesting. Like in this paper over here, okay, this is one of Jeffrey's papers. I haven't read it yet, but I'm gonna read it later. I saw actually I'm gonna get into like a different thing later on. Yeah. So basically over here it says the learning that is being done is always based on some sort of observations of data, such as examples. Most common the most common case in this course, direct experience or instruction. So in general, machine learning is about learning to do better in the future based on what was experienced in the past. So it's not copying and pasting, guys. It's learning. It's reasoning. It's literally doing stuff. It's figuring, which is kind of scary when you think about it. But it's scary in a beautiful kind of way. I think we can also take the time to try to figure out how machine learning can actually like take the way we actually learn really like day-to-day life. You know, because I feel like when I learn something, I feel like I just skim through it and I just take what I want to hear or what I want to learn about, and I don't take it. I don't take all of it, and I don't try to like like abstract it and understand it. For example, like over here. Hold on, give me a second. I'm currently reading this book that I got. That I got. Um, I, I got this book on campus for like $5. It's called Robot Modeling and Control. I'm on what like I just started reading it. I'm like on page 20, basically, and it's just talking like about like actuators, like degrees of freedom and everything. I read it right, but I'm not taking everything in. I'm seeing stuff. You know what I'm saying? Like I can see it, I can read it, but I'm not understanding it the same way I thought I'd understand it. You know, I'm just reading like a few parts. I'm like, okay, degrees of freedom, rotation here, actuators here, um, transistive, blah 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 blah, other stuff. You know what I'm saying? Or even over here, like I have a notebook of like just like a bunch of basic physics, like formulas and stuff. So no, I can always go back to and look at it. Because I wrote that when I was like maybe like 17. I'm like almost 23 now. I'm like I and I still don't like memorize all of that stuff. So I just constantly look at it. I'm like, okay, I'm gonna like need it in the future. I'll need that in the future, and I'll figure stuff out. But then just to like cut to the short, because I actually have like no idea what I want to even think about right now. I was just thinking about this total about now. I'm realizing I'm kind of tired because I like didn't sleep properly. Anyway, Jeffrey is also a Nobel Prize co-winner, right? For his like for his research on this stuff. and he's also very much against the fact that we're he's very much against the fact that these large like these large language models aren't being as regulated as they should be, because yes, artificial intelligence and neural, like just like machine learning, there's so much potential for it to like just be like a big thing, like there really is a chance that we might get a utopia, this form of intelligence that's smarter than us might allow us to just live lives where we're worry free and we just focus, on doing things like we can just focus, like more on like just discovery and not solving problems. Maybe some Star Trek future. Yes, there'll always be some aspects of humanity that can't be changed, I think. But with this super intelligence, there's a chance we might live, in a world where, you know, limited intelligence will no longer be a problem. Because I actually saw a video before, I think I can find it right now. Let me get this man's name.
For anyone struggling with ear ringing, do not drink cold.
Oh no. No. There you go. I'm not editing this, but it was around here somewhere. There it is.
We've just heard of Geoffrey Hinton leaving recently.
Geoffrey Hinton, give some context to that.
Geoffrey is sort of the grandfather of AI, one of the very, very senior figures of AI at Google. We all believed very strongly that this will make the world better, and it still can, by the way. There is a scenario, possibly a likely scenario, where we live in a utopia, where we really never have to worry again, where we stop messing up our planet, because intelligence is not a bad commodity. More intelligence is good. The problems in our planet today are not because of our intelligence. They are because of our limited intelligence. Our intelligence allows us to build a machine that flies you to Sydney so that you can surf, okay? Our limited intelligence makes that machine burn the planet in the process. We've just heard of Geoffrey Hinton.
That makes sense, bro. You know what I'm saying? Like, imagine if we had this on our side. Imagine if we had like all of this intelligence on our side to like build machines and just build tech, to do stuff, not to solve problems, but to just do stuff. You know what I'm saying? Like to do stuff. Yeah, there's always a lot of contradictions or like exceptions or like what ifs. Like a lot of what ifs. But who knows? We're living in a world right now where this is possible and it is happening right now. 10 years ago, nobody even thought about everyone thought the only type of artificial intelligence we could think of was the shit in Terminator, and we're like, okay, nobody wants Skynet taking over the world. We live in a world now where OpenAI is a thing, and that shit is accelerating, okay? AGI is a thing too. I think he even has like a paper about this shit, man. He's a lot of papers about this. I don't know. Some of them might mention AGI. I know this video mentions AGI at the end. The road to AGI, bro.
Do you think that the learning algorithms matter that much, or is it just the scale? Are there basically millions of ways that we could get to human level in intelligence, or are there sort of a select few that we need to discover?
Yes, so this issue of whether particular learning algorithms are very important, or whether there's a great variety of learning algorithms that will do the job, I don't know the answer. It seems to me, though, that backpropagation, there's a sense in which it's the correct thing to do. Getting the gradient so that you change a parameter to make it work better, that seems like the right thing to do, and it's been amazingly successful. There may well be other learning algorithms that are alternative ways of getting that same gradient, or that are getting the gradient to something else and that also work. I think that's all open and a very interesting issue now about whether there's other things you can try and maximize that will give you good systems. And maybe the brain's doing that because it's easier. But backprop is, in a sense, the right thing to do. And we know that doing it works really well.
And
Yeah, I gotta do a lot of studying. Backward propagation. He just said right now that's the best way to do this shit. For your system to learn fast and right. So yeah, that's about it.